It's weird how jobs say they care a lot about computer science, but then in interviews, they only cover like 5% of a CS curriculum. Now, I'm not saying that we need to make interviews harder, they're already a farce. But by overemphasizing these abstract fundamentals, people hear less about the really cool, concrete stuff that they could use every day. Today, let's talk about a powerful tool that can make your life easier, whether you're just throwing buttons on a screen, fixing colors in an image, or navigating data that transcends time and space. Today, let's talk about transformation matrices. For our example, we're going to use Halide for iPad. Now, we designed it so that the capture button is on the right edge of the screen so that you could tap it with your thumb. But then once we sent out a build to friends, it turns out we forgot some people are left-handed, so we decided to add a mode that would flip the buttons to the opposite edge of the screen. We're going to code this out, but let's start by doing things the hard way. Inside our layout code, we need to find the X and Y position of the capture button. Now, in left-handed mode, we can choose any number we want for X, like 50 points. And then for Y, we want the button to be centered on the screen, so we're going to take the height of the screen and divide it by 2. In right-handed mode, we can calculate Y just like we did before, but to calculate X, we're going to take the width of the screen and subtract 50. Not too bad, except there's already a button on the opposite side of the screen, so we're going to have to wrap that in an if statement and do similar math to calculate its opposite position. And it actually turns out there's like a half dozen buttons that make up the screen, so we have a lot of if statements. And there are ways to pretty this up by just wrapping it in helper functions, but I don't think that that's really cleaning things up as so much as sweeping the problem underneath the rug. Like when I run into this kind of complexity, I like to take a step back and ask whether I fully understand the problem I'm actually trying to solve. It feels like there should be some kind of tool to mirror an element on screen, kind of like the mirror button in a drawing tool like Sketch. What if I told you this tool exists? And it's called a transformation matrix. Think of a matrix as a function that you create on the fly. When you pass a point through your matrix, you end up with a new point, one that's been moved, or rotated, or scaled. And you can combine together multiple transforms to end up with a complex operation, like one that finds the mirror position on screen along the center of the screen. So in the final version of our code, all that we do is design the app as if it's right-handed. And then at the end, if it turns out the user's left-handed, we loop through all the buttons on screen and apply a matrix transform to flip the position. Now you might say, I could write that layout code. Besides, matrices sound complicated. And I'd point out that every platform already includes functions for creating, manipulating, and applying transforms for you. You just need to look for them. And I've used a very simple layout problem, but with more complicated rules, transforms clearly win out. Like, imagine if we let the user put buttons on any of the 4 edges of screen. Now you'd have to write your layout code 4 times. Or you could use a simple transform that rotates a position along the center of the screen. And as a bonus, you're ready for when Apple ships a 6-sided iPad. Matrices seem foreign at first, but so does everything in code. Once you've used them for a bit, they feel as natural as loops or if statements. Maybe we should go a little bit deeper to demystify them. Unfortunately, it's difficult to describe what a matrix is. It's easier to see for yourself. A matrix is just a grid of numbers. This one does nothing. If you apply it to a point, it just returns the original point, kind of like how multiplying any number by 1 returns the original number. But if we alter numbers in our grid, it'll have different effects on the point. Like altering these numbers will move the point, altering these numbers will scale it, and altering these numbers will rotate it. Now, what actually happens when you apply a matrix to a point? It's a bit monotonous, but it's simple. To flip the point, we're going to scale it by -1 and move it 1 screen width to the right. First, you take the original position and you add an extra 1 to the end. Then, you go row by row through your matrix, and you multiply each element in each column with each element of your point. You add together each of the elements in each of the row, and you end up with a transformed point. Your platform includes all of the functions to handle this for you, but hopefully this walkthrough slightly demystified what's going on. So I've included a link in the description to an awesome video series that dives deeper into the math, and it really helps you develop an intuition for what's happening. And it also uses the correct terminology everywhere. You see, I've been playing fast and loose because today I just wanted to show that this magic isn't that complicated relative to the power that this stuff gives you. And believe me, this stuff is used everywhere. When your operating system goes to render views on screen, it's just looping through every view and applying a transform matrix. And if you add a row and column to your matrix, now you can go from 2D graphics to 3D models. And that's useful beyond 3D rendering and video games. Like if you have any data that consists of 3 elements, you can map it into a 3D space and apply a transform. Oh, hey, color has 3 values. Cool. And if you add another row and column, now you can work in 4D spaces. Time. Add another row and column, and now you can work with data that transcends human comprehension. Like with a large enough matrix, you can work with data in 100-dimensional spaces. I think that matrices illustrate the power of computer science because very often you're going to run into problems that, yes, you can brute force through, and then you can tidy up the code to look pretty. But rather than grinding on code, a little bit of theory allows you to take a step back and change your perspective. It allows you to look beyond the code, and when it clicks, it feels like you sort of wake up.